Okay, so we're going to deal with the quadratic formula, but before we talk about the quadratic formula, I want to talk about the discriminant again, just as a reminder. Who remembers what the discriminant is? Shaylin?
The negative b squared square root of b squared 4ac?
Way too much stuff. No. Mackenzie?
B squared minus 4 times c.
Perfect. It is just what's underneath the square root. Okay? So b squared minus 4ac. And in the last unit, we talked about what happens based on what the discriminant is, right? So if we had a positive number, what did that tell us? If our discriminant was a positive number? 2 real solutions. What happened if our discriminant was 0? 1 real solution. And if we had a negative number, 2 imaginary solutions. So now that we know more about imaginary solutions, this tells us that we have a negative underneath our square root, which means we're going to have an I. That's the only difference. Okay. On this test, you are going to be asked to determine if the following statement is true or false. So, is the following So let's see. The equation. Okay, so if I give you the equation, negative x squared plus 3x plus 9, and I'm saying it has 2 imaginary solutions, how could I determine if that statement is true or false? Huh? By having 2 negatives? Okay, so let me re-ask the question. 2 imaginary solutions should trigger your brain to think about what? That means there's a negative for what? The discriminant. Okay, so if it's talking about the number of solutions, we're talking about the discriminant. So how can I determine if there's a negative for my discriminant? Actually use the discriminant, right? You have the information here, so let's plug it in. What is b? 3, so 3 squared minus 4 times a times c. Three squared is 9. Negative 4 times negative 1 is positive 4. 4 times 9, 36. 9 plus 36, 45. So based on the discriminant, are there 2 imaginary solutions?
No.
No. There's 2 real solutions. So this statement's false. There are 2 real solutions. Okay, so if I were to solve using the quadratic formula, I'm going to get 2 real answers. There won't be an I in it, and there will be a plus or minus. Okay, we'll have 2 answers. So I'd like you to try these 2. So if I give you the equation x squared plus 3x plus 9, and I'm saying it has 1 real solution. And then I also want you to look at the equation negative x squared minus 3x plus 9, and I'm saying it has two real solutions. Okay, so take a second and I want you to see if those statements are true or false. So for number 2, let's see. We have 3 squared minus 4 times a times c, which is 9 minus 36, which gives you negative 27. So is that going to have one real solution? No. What is it going to have? Two imaginary solutions. Now, no, on the test, it's not going to say use a discriminant to determine if the following statements are true or false. You need to know that. So if you're looking at any types of solutions, you need to know what the discriminant is and when to use it. Okay, and then the last one, we have negative 3 squared minus 4 times a times c. So I'm getting 9 plus 36 again. Yep. Which gives me 45. That is a true statement. Any questions about using the discriminant to determine if those statements are true or false? Okay, so let's remind ourselves of the quadratic formula for those of us that have forgotten it. You remember it? So quadratic formula, because you're going to need it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So everything's still going to work the same like it did in the last unit. The only thing that we could potentially see at this point is a negative underneath the square root, which means we have an imaginary solution. But we solve it exactly the same. Okay, so we hopefully will be better at this than we were the last time. So let's start with this first one. So 3x squared plus 2x plus 1 equals 0. What's important about our equation before we plug it into the quadratic formula? It needs to be in standard form, right? It needs to be in standard form and set equal to 0. Is this one in standard form? Okay. So A is 3, B is 2, C is 1. Let's plug it in. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So let's keep going. Negative 2 plus or minus the square root of 4. Negative 4 times 3 is negative 12. Negative 12 times 1 is still negative 12, right? What is 4 minus 12? Negative 8. So this, remember, is your discriminant. How many answers or solutions are you going to have? 2 imaginary solutions, which means there's an I in your answer. So negative 2 plus or minus, what does 8 break down to? 2 square root of 2. We're pulling out the I as well, because there's a negative. All over 6. So nothing changed with how we solved that other than we pulled out the I. Are we okay with that final answer? You do need to simplify it. So you're looking for a number that goes into 2, 2, and 6. 2. So 1, 1, and 3. Final answer is going to be x equals -1 plus or minus 1i, or just I, square root of 2 over 3. Are we okay with that? So if you were okay with the quadratic formula the first time around, this shouldn't be any different other than that negative. And just like yesterday when we were talking about square roots, you may or may not get an I in your answer. I may throw in some that don't have I's, so you just have to be careful.
Is it possible to do completing the square and all that with this?
We're not going to do completing the square. We're just going to do taking square roots and quadratic formula. Completing the square is a little harder. Not much, but a little bit. Are we okay with that? Okay. Let me give you one more, and I think we can be done. Let's do... So 7n squared plus n minus 1. I'm going to let you work on that with your group. Did you write it in standard form before you started? So you added 1 to both sides? Okay, so 7n squared plus n plus 1 equals 0. That's step 1. It has to be in standard form. Then you should have n equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Still good? Okay. N equals -1 plus or minus, so 1 squared is 1, and then we have minus 28. So you end up with a -27 underneath the square root, all over 14. So 27 breaks down to 9 and 3 and 3 and 3. So I have a pair of 3's. So n equals -1 plus or minus. The 3 comes out, and I comes out. 3 stays inside, all over 14. The last thing you should check is if there's a number that goes into 1, 3, and 14. And in this case, that answer is no. Did you end up with this final answer? Awesome.